Hello, in this video, we're now going to make the minimax algorithm. So what I'm going to do is I'm at this site, and these are chess people, and they use they use these kind of things. Okay, so I'm going to look at the min-max search here, and the code is here. It talks about it here. If you want this size, I don't know if you can. You should be able to see this. That is the site. In fact, that's not the site. I'm going to copy and paste the site somewhere. Right, this is the site. I got to it through a different place. However, that's the site if you want to get to it. Okay, so this will tell you about minimax, and it will tell you the different ones. Now, this shows you how it works, and it will give you the formula for doing it. For example, it's got depth less than naught, it's got return, evaluate, generate legal moves, and that's what this output is going to make. On make move, make next move, return best, generate legal move, etc. So this is something that we're going to use. But there's two of them. There's this one here, and there's the other one that they call it. What does he call it? He calls it Negamax. It does exactly the same thing. However, it flips the bit, as in, you remember that? You remember that thing I showed you with the min max, and all the numbers were positive, and it says red is the minimizer and black is the red and yellow. One is minimizer, one is maximizer. With this one, that's what it will do. It will sort of, all the values will be, whoever is winning, it will be positive. So that means if it's 100, that means someone's winning, whether it's black or yellow or whatever. Okay, it's hard to explain, but anyway, this is what we're gonna use. The one we're gonna use is gonna be more like this. Okay. However, as he says here, hardly no one uses min-max, but it's not very good. What you want to use is alpha beta. Okay. So I'm going to start putting the code in now. Let me just get rid of this. So we need a function. And let's call it min-max. And it's going to take the board. It's going to take the side. And it's going to take the depth. And the first thing I'm going to do is I'm going to paste in some constants. Not constants, but some variables. I'm going to talk about them. We've got the move list. We've got the move count. The move list is the legal moves. Because let me go back to here. You have to generate legal moves here. So that's what that's going to do. That's going to store the legal moves in the move list. The move count is the amount of legal moves. The best score, this value has got to be less than, in fact, I could do something better than this. What I'm going to do is I'm going to put a new variable in here. I'm going to do a new constant, and I'm going to call it in infinity I'm going to set it to 200 for the time being. So best score, I'm going to put minus infinity score minus infinity. So what I want, the reason why I'm putting it at that value is the first time it runs through, whatever score it finds, even if it finds a loss, I want it to make that bit to be the best score. So if it goes through once and it's I'm losing and it's minus 100, it will give me a move. If I set that to minus 50, it would say that this, I don't want it ever to, every single move should be better than this move. That's why I'm calling it minus infinity. Okay? So that's the first thing it's going to do. It's going to start with the best move, best score and best move at minus infinity. Okay? Now, we need something. I've got some variables up here. Right, let me just shut some of these things down. These are just for our interest because we need to know. We just want to see how much positions we're searching, what's the max supply, and what's the best score. Okay? So we're going to put something in to do a little count. So we want to see how many times this gets called. So I'm going to put some stuff in just to do some counting. Okay? And that is just for counting. So what that would do is, if the apply, it will come here and say if the apply is more than the max apply equals apply. So that what it's going to do is, it's going to just keep a tally of the max apply so that we need to know the max apply, and also positions. That is every single time this gets run, it's going to get incremented by 1. So that will tell us how much times, how much positions we went to. Okay, so that's what that's for. Now, if I go to get computer move here, let best equals, can you see best is, that is actually a move. So it's returning a move. It's not returning a score, it's just returning the move. It's also going to print, and it's also going to print the positions, it's going to print the max point, and it's going to do the best final score. So that's going to be the score, but it's going to actually return a move. That best is a move. So we need something to, we're going to put a line and I'll explain what this does. If the, obviously, when it goes on the tree, imagine that's the top of the tree, it would only return when it gets to the top of the tree, i.e. when the ply is 0. So what this is saying is, if the ply is more than 0, right, but at the moment this is the first ply, so it's not going to return anything. However, when we go deeper down into position, for example, what if it went down, what if it went down position once, and then what I want it to do is look at the board and see, is it a draw? Basically, this is saying, is it a draw? If score not equal to 0, return score. So what that's saying is, if either side has 1, it's just going to return the score. Right, so that, remember that position where it shows you where it broke, some of them went all the way down to the bottom of the tree, and then it's finished because there's no more moves. Some of them, when it finds a win, it breaks and stops. So this is that. So what this is saying is, when the ply is more, whenever the ply is more than 0, it's going to check the board to see if anyone's winning. If no one's winning, it's going to carry on. Otherwise, it will just return a score. Okay, now you see what I mean. I'm gonna run through the code in the console so you can step through it and see everything what's going on. Okay, so that's what that's doing. Another thing we have to do is, perhaps we could put both of these together. We need to check the depth. We're going to set a maximum depth because we don't want it to go on forever. So similar to that one, this one, if the depth is less than or equal to 0, it's just going to return the score. So it's going to be, if it's, whether it's, it doesn't matter what, it will return 0. Whereas this one would only return if someone's won. This one will return, if you're just going to return a score, it doesn't matter because you're just going to think, okay, you've reached the maximum depth, we're not going on. Okay, so that would also break it out. So at the moment, we're going to run a recursive function. These two are the things that will break it out of the recursive function. Okay. So now I'm going to do another. Now I'm going to proceed now with the next thing, and it's going to be familiar to you. What we want to do is we want to fill the move list. Okay, so I'm going to pause the video because I need to show another slide and I forgot about this, but I'm going to pause the video and I'm going to get this slide off. Okay, here it is. So what we want to do is we want to find all legal moves. So what we do is we're going to loop the top here, and then we're going to, that function that we created called, where is it again? Legal move, that legal move. We're going to run across here and we're going to run legal move on each one, and that would tell us which legal moves are in the position. Okay. So all I'll do is I'll paste it in and then I'll talk about it. Okay. So that will fill the loop. So as you can see, this here, the index, I'll bring it back up. The index starts at 1 and it carries on to this less than board WW. So it should stop there. In fact, I'm gonna have to, let me check something. I need to just check something. Okay, I think I made a mistake here. I think that should be -1, but I can check that anyway. However, that does, so I'm gonna check that, but I'm sure it may well be -2 in fact. Let's have a look. 1 less than 8. I think it's -1. So what it is, even if I set it as it was, what it would do, it would come here and it wouldn't give that as a board. So that what would happen is it will probably run 10% better because it's gonna do less. It's gonna do less checking. It probably won't make much of a difference. But anyway, what this does, it actually comes across the top here and it will say, there's a legal move. Get me a legal move, get me legal, get me legal. So it will find 10, 56, 39, 22, 30, 23, 33, 44. If that was the position, that's what it would find. Okay. So basically, let's just say it fills the move list. So it loops across the top item equals legal move. If item not equal to -1, it will go move list, move count. So that means it will create an array. It will create an array with the moves. For instance, it will create an array. In this case, it will create an array with 10, 56, 39, etc., etc. So that's what this does. So that will fill the move list. And after you fill the move list, then it will start processing moves. I'm just looking at something. In fact, the video's been running a bit long now. So what I'll do is I'll stop the video now and I'll continue on another video. Thanks for listening. Okay, bye.